Okay, so this should be your thermodynamics test review. First thing is a bunch of definitions, so let's talk about those. We want to talk about the fact that energy is the ability to do work, measured in joules or calories. Okay, kinetic energy is the energy of motion. The equation is Ke equals 1/2 the mass times the velocity squared. Potential energy has several forms. We can talk about the potential energy of distortion, which would be a rubber band or a spring, compressed spring, stretched rubber band, or a stretched or compressed spring. We can talk about the potential, and that takes care of the distortion. The chemical energy, chemical potential energy, and we're going to call that the energy stored in chemical bonds. Energy stored in chemical bonds. Or we can also talk about the potential energy that's called gravitational energy, potential energy. That would be the potential energy due to your position. So if I say that a textbook has no potential energy when it's sitting on the ground and I move it to the top of a table, I can talk about the potential energy of the textbook as it rests on top of the table, because I know that if it gets an opportunity to fall, it can do work by falling a distance and smashing a bug or whatever you want to smash. Okay? So if you need time to copy those, pause it and copy them, because I'm fixing to clean them up and go on to the next one. All right, heat is the energy associated with the changing temperature of an object. Energy associated with the changing temperature of an object. So as an object cools down, heat is given off. As an object heats up, energy is taken in. Work is simply a force applied over a distance. And we know that it takes energy to do work. Okay. Entropy is the disorder of a system. Okay. So, and the symbol for it is a delta S. And we talked about this in my classroom. Your bedroom at your house starts out nice and neat. Mom says clean it. You get it all cleaned up. And then over a period of time, it gets all messed up again. It goes and gains entropy, which is just disorder. And it's easier for it to gain disorder than not, because it's easier to make a mess than it is to clean it up, basically is how I look at that. All right, so I'm going to clean that up, and I'm going to go on to letter G. Gibbs free energy is the delta G is the symbol, and it is simply the maximum amount of energy that can be coupled to another process to do work. That can be coupled or are hooked up to. Another process to do work. Okay. Enthalpy is heat content of a system at constant pressure. Heat content of a system at constant pressure. So if you did the lab where we had the metal samples and we took them from being cool metal samples to hot metal samples, and then we took that hot metal sample and put it in our calorimeter, we could talk about the enthalpy of the calorimeter. Temperature is a measure of the average kinetic energy of the molecules in an object. The measure of average kinetic energy of the molecules in a substance. Okay, I'm going to clean those up, so if you need to look at that, you pause it and see what's going on, write it down. Law of conservation of energy, we've known this and heard it millions of times probably. Energy cannot be created or destroyed. We can change forms of energy. The forms of energy can be changed. But the total amount of energy present has to be accounted for. It has to remain constant. All right, what has more entropy, a tidy room or a messy room? We already talked about that. A messy room has more disorder or more entropy. Since there is more disorder. All right. Are heat and temperature the same? No, they are not. We've already defined them, so look at your definitions. Heat can be measured in calories or joules. All right. Okay, so let's clean those up and move on. All right, the next statement says describe the kinetic theory of matter. Molecules are always in motion. Can be measured with a thermometer, and that's called the temperature. The greater the material's internal energy, the higher the temperature of that material. Okay. Heat is the flow of energy between objects of different temperatures. Heat flows from hot objects to cold objects. Oh, sorry, that looked terrible. Cold. All right. Describe the three ways that heat can be transferred. Conduction means that we have to have contacts between two objects. And heat is going to flow from the hot to the cold. Convection, transfer of heat through convection, is accomplished by the fluid movement. Okay, babe, take care. That should say currents. Like warm air rising. And you see these as convection ovens, and that's all you're doing is moving that warm air around in the oven. Instead of letting it rise and just fill the box, you move it. Radiation is accomplished by electromagnetic waves, such as the sun or the microwave oven. Microwave ovens use electromagnetic waves. There we go. All right, melting occurs during the transition from solid to liquid. Freezing occurs during the transition from liquid to solid. We're removing heat. Here we're putting heat in, here we're taking heat out. Condensation occurs during the transformation from a gaseous state to a liquid. Vaporization occurs during the transition from a liquid to a gas. Here we're removing heat, here we're putting heat in. Sublimation, we skip from a solid to a gas. And deposition occurs when we go from a gas to a solid. Example of that would be frost. Dry ice is the best example of this. And CO2 is prone to sublimation. So I'm going to stop and then I will go on with another recording.